And Section 3, Exploring the System. Now that we know how to move around the file system, it's time for a guided tour of our Linux system. Before we start, however, we're going to learn some more commands that will be useful along the way. ls list directory contents, file, determine file type, less, view file contents. Having more fun with ls. The ls command is probably the most used command, and for good reason. With it, we can see directory contents and determine a variety of important file and directory attributes. As we have seen, we can simply enter ls to get a list of files and subdirectories contained in the current working directory. So, ls, hit enter, and you get your list. Besides the current working directory, we can specify the directory to list, like so. ls space /usr. We can even specify multiple directories. In the following example, we list both the user's home directory, symbolized by the tilde character, and the /usr directory. So ls space tilde space /usr. So //usr : We can also change the format of the output to reveal more detail, like ls space -l. By adding -l to the command, we change the output to the long format. Options and arguments. This brings us to a very important point about how most commands work. Commands are often followed by one or more options that modify their behavior, and further, by one or more arguments, the items upon which the command acts. So most commands look kind of like this. Command space -options space arguments. Most commands use options which consist of a single character preceded by a dash. For example, -l. Many commands, however, including those from the GNU project, also support long options, consisting of a word preceded by 2 dashes. Also, many commands allow multiple short options to be strung together. In the following example, the ls command is given 2 options, which are the L option to produce long format output and the T option to sort the result by the file's modification time. So ls space -lt. We'll add the long option, quote, -- reverse, unquote, to reverse the order of the sort, like ls space -lt space -- reverse. Note that command options, like file names in Linux, are case sensitive. The ls command has a large number of possible options. The most common are listed in table 3-1. 3-1, common ls options. Option -a, long option --all. So that list all files, even those with names that begin with a period, which are normally not listed, that is, hidden. Option -A, long option almost -all, so -almost -all. Like the -a option above, except it does not list. Current directory and so dot parentheses current directory and double dot parentheses parent directory. Option dash D, long option dash dash directory. That's dash dash directory. And ordinarily, if a directory is specified, ls will list the contents of the directory, not the directory itself. Use this option in conjunction with the -L option to see details about the directory rather than its contents. Option -F, long option --classify, so --classify. This option will append an indicator character to the end of each listed name. For example, a // if the name is a directory. Option -H, long option --human-readable. So that's --human-readable. So in long format listings, display file sizes in human readable format rather than in bytes. Option -L, that just displays the results in long format. -R, the long option is --reverse, and that will display the results in reverse order. Normally, ls displays its results in ascending alphabetical order. -S, sort results by file size. -T, sort by modification time. A longer look at long format. As we saw earlier, the -L option causes ls to display its results in long format. This format contains a great deal of useful information. Here is the examples directory from an Ubuntu system. Table 3.2 provides us with a look at the different fields from one of the files and their meanings. Okay, so the field -rw-r --r-. The meaning is access rights to the file. The first character indicates the type of file. Among the different types, a leading dash means a regular file, where a D indicates a directory. The next three characters are the access rights for the file's owner. The next three are for members of the file's group, and the final three are for everyone else. Chapter 9, Permissions, discusses the full meaning of this in more detail. Field 1. File's number of hard links. See the sections Symbolic Links and Hard Links later in this chapter. Field root, the username of the file's owner. Field root, the name of the group that owns the file. 32059, size of the file in bytes. (2007-04-03-11:05), date and time of the field's last modification. 00-cd-cover-odf, name of the file. Let's see, having more fun with ls. Determining a file's type with file. Capital F file's type with lowercase f file. As we explore the system, it will be useful to know what files contain. To do this, we will use the file command to determine a file's type. As we discussed earlier, file names in Linux are not required to reflect a file's contents. while a file name like picture.jpg would normally be expected to contain a JPEG compressed image. It is not required to in Linux. We can invoke the file command this way: file space and file name in italics. When invoked, the file command will print a brief description of the file's contents. For example, file space picture.jpg. So the file command will print a brief description of the contents. All right, there are many kinds of files. In fact, one of the common ideas in Unix-like operating systems, such as Linux, is that everything is a file. As we proceed with our lessons, we will see just how true that statement is. While many of the files on our system are familiar, for example, MP3 and JPEG, there are many kinds that are a little less obvious and a few that are quite strange. Viewing file contents with less. The less command, LESS, is a program to view text files. Throughout our Linux system, there are many files that contain human-readable text. The LESS program provides a convenient way to examine them. Okay, what is, quote, capital T-E-X-T, unquote? So what is, quote, text? There are many ways to represent information on a computer. All methods involve defining a relationship between the information and some numbers that will be used to represent it. Computers, after all, only understand numbers, and all data is converted to numeric representation. Some of these representation systems are very complex, such as compressed video files, while others are rather simple. One of the earliest and simplest is called ASCII text, ASCII, pronounced ASCII, is short for American Standard Code for Information Interchange. This is a simple encoding scheme that was first used on teletype machines to map keyboard characters to numbers. Text is a simple one-to-one mapping of characters to numbers. It is very compact. 50 characters of text translates to 50 bytes of data. It is important to understand that text only contains a simple mapping of characters to numbers. It is not the same as a word processor document, such as one created by Microsoft Word or LibreOffice Writer. Those files, in contrast to simple ASCII text, contain many non-text elements that are used to describe its structure and formatting. Plain ASCII text files contain only the characters themselves and a few rudimentary control codes such as tabs, carriage returns, and line feeds. Throughout a Linux system, many files are stored in text format, and there are many Linux tools that work with text files. Even Windows recognizes the importance of this format. The well-known Notepad.exe program is an editor for plain ASCII text files. Why would we want to examine text files? Because many of the files that contain system settings, called configuration files, are stored in this format, and being able to read them gives us insight about how the system works. In addition, some of the actual programs that the system uses, called scripts, are stored in this format. In later chapters, we will learn how to edit text files in order to modify system settings and write our own scripts. But for now, we will just look at their contents. The less command is used like this: less space file name. Once started, the less program allows us to scroll forward and backward through a text file. For example, to examine the file that defines all the system's user accounts, enter the following command: less /etc/passwd. Once the less program starts, we can view the contents of the file. If the file is longer than one page, we can scroll up and down. To exit less, press the Q key. The table below lists the most common keyboard commands used by less. So less commands: page up or B. The action is scroll back one page. Page down or space, scroll forward one page. Up arrow, scroll up one line. Down arrow, scroll down one line. Capital G, move to the end of the text file. One capital G or lowercase g, move to the beginning of the text file. / characters, search forward to the next occurrence of characters. N, lowercase n, search for the next occurrence of the previous search. H, display help screen. Q, quit less. Less is more. The less program was designed as an improved replacement of an earlier Unix program called more. The name less is a play on the phrase less is more, a motto of modernist architects and designers. Less falls into the class of programs called pagers, programs that allow the easy viewing of long text documents in a page-by-page manner. Whereas the more program could only page forward, the less program allows paging both forward and backward and has many other features as well. Taking a guided tour. The file system layout on a Linux system is much like that found on other Unix-like systems. The design is actually specified in a published standard called the Linux Filesystem Hierarchy Standard. Not all Linux distributions conform to the standard exactly, but most come pretty close. Okay, we're still in Exploring the System, Section 3. Next, we are going to wander around the file system ourselves to see what makes our Linux system tick. This will give us a chance to practice our navigation skills. One of the things we will discover is that many of the interesting files are in plain, human-readable text. As we go about our tour, try the following. 1. CD into a given directory. 2. List the directory contents with ls -l. 3. If you see an interesting file, determine its contents with file, that's F-I-L-E. 4. If it looks like it might be text, try viewing it with less, L-E-S-S. 5. If we accidentally attempt to view a non-text file and it scrambles the terminal window, we can recover by entering the reset command, R-E-S-E-T. Remember the copy and paste trick. If you're using a mouse, you can double-click on a file name to copy it and middle-click to paste it into commands. As we wander around, don't be afraid to look at stuff. Regular users are largely prohibited from messing things up. That's the system administrator's job. If a command complains about something, just move on to something else. Spend some time looking around. The system is ours to explore. Remember, in Linux, there are no secrets. Table 3-4 lists just a few of the directories we can explore. There may be some slight differences depending on our Linux distribution. Don't be afraid to look around and try more. All right, Table 3-4, directories found on Linux systems. Directory / that's the root directory where everything begins. /bin contains binaries or programs that must be present for the system to boot and run. /boot, B-O-O-T, contains the Linux kernel, initial RAM disk image for drivers needed at boot time, and the bootloader. Interesting files: /boot /grub /grub.conf or menu.lst, which are used to configure the bootloader. /boot /vmlinuz or something similar. That's the Linux kernel. Directory /dev. This is a special directory that contains device nodes. Everything is a file also applies to devices. Here is where the kernel maintains a list of all the devices it understands. /etc. The /etc directory contains all of the system-wide configuration files. It also contains a collection of shell scripts that start each of the system's services at boot time. Everything in this directory should be readable text. Interesting files. While everything in /etc is interesting, here are some all-time favorites. /etc /crontab, a file that defines when automated jobs will run. /etc /fstab, a table of storage devices and their associated mount points. /etc /passwd, a list of the user accounts. /home or home. In normal configurations, each user is given a directory in /home. Ordinary users can only write files in their home directories. This limitation protects the system from errant user activity. /lib contains shared library files used by the core system programs. These are similar to dynamic link libraries, DLLs, in Windows. /lost plus found, LOST plus FOUND. Each formatted partition or device using a Linux file system, such as ext4, will have this directory. It is used in the case of a partial recovery from a file system corruption event. Unless something really bad has happened to our system, this directory will remain empty. /media, MEDIA. On modern Linux systems, the /media directory will contain the mount points for removable media such as USB drives, CD-ROMs, etc., that are mounted automatically at insertion. /MNT. On older Linux systems, the /MNT directory contains mount points for removable devices that have been mounted manually. /OPT. The /OPT directory is used to install optional software. This is mainly used to hold commercial software products that might be installed on the system. /PROC. The /PROC directory is special. It's not a real file system in the sense of files stored on the hard drive. Rather, it is a virtual file system maintained by the Linux kernel. The files, quote, the files, in quotes, it contains are peepholes into the kernel itself. The files are readable and will give us a picture of how the kernel sees the computer. /root, R-O-O-T. This is the home directory for the root account. /SBIN. This directory contains system binaries. These are programs that perform vital system tasks that are generally reserved for the superuser. /TMP. The /TMP directory is intended for the storage of temporary, transient files created by various programs. Some configurations cause this directory to be emptied each time the system is rebooted. /USR. The /USR directory tree is likely the largest one on a Linux system. It contains all the programs and support files used by regular users. /USR/bin. The /USR/bin contains the executable programs installed by the Linux distribution. It is not uncommon for this directory to hold thousands of programs. /USR/lib. The shared libraries for the programs in /USR/bin. /USR/local, local. The /USR/local tree is where programs that are not included with the distribution but are intended for system-wide use are installed. Programs compiled from source code are normally installed in /USR/local/bin. On a newly installed Linux system, this tree exists, but it will be empty until the system administrator puts something in it. That was /USR/local/bin. All right, /USR/SBIN contains more system administration programs. /USR/SHARE. The /USR/share contains all the shared data used by programs in /USR/bin. This includes things such as default configuration files, icons, screen backgrounds, sound files, and etc. /USR/SHARE/DOC. Most packages installed on the system will include some kind of documentation. In /USR/SHARE/DOC, we will find documentation files organized by package. /VAR. With the exception of /TMP and /HOME, the directories we have looked at so far remain relatively static. That is, their contents don't change. The /VAR directory tree is where data that is likely to change is stored. Various databases, spoof files, user mail, etc. are located here. /VAR/log. /VAR/log contains log files, records of various system activity. These are important and should be monitored from time to time. The most useful ones are /var/log/messages and /var/log/syslog. Note that for security reasons, on some systems, only the superuser may view log files. Symbolic links. As we look around, we are likely to see a directory listing, for example, /lib, with an entry like this. Notice how the first letter in the listing is L, and the entry seems to have two file names. This is a special kind of a file called a symbolic link, also known as a soft link or symlink. In most Unix-like systems, it is possible to have a file referenced by multiple names. While the value of this might not be obvious, it is really a useful feature. Picture this scenario. A program requires the use of a shared resource of some kind contained in a file named, quote, FOO, unquote. But foo has frequent version changes. It would be good to include the version number in the file name so the administrator or other interested party could see what version of foo is installed. This presents a problem. If we change the name of the shared resource, we have to track down every program that might use it and change it to look for a new resource name every time a new version of the resource is installed. That doesn't sound like fun at all. Here is where symbolic links save the day. Suppose we install version 2.6 of foo, which has the name foo-2.6, and then create a symbolic link simply called foo that points to foo-2.6. This means that when a program opens the file foo, it is actually opening the file foo-2.6. Now everybody is happy. The programs that rely on foo can find it, and we can still see what actual version is installed. When it is time to upgrade to foo 2.7, we just add the file to our system, delete the symbolic link foo, and create a new one that points to the new version. Not only does this solve the problem of the version upgrade, but it also allows us to keep both versions on our machine. Imagine that foo 2.7 has a bug. Those developers. And we need to revert to the old version. Again, we just delete the symbolic link pointing to the new version and create a new symbolic link pointing to the old version. The directory listing at the beginning of this section from the /lib directory of a Fedora system shows a symbolic link called libc.so.6, libc.so.6, that points to a shared library file called libc-2.6.so. This means that programs looking for libc.so.6 will actually get the file libc-2.6.so. We will learn how to create symbolic links in the next chapter. Here's the lib.so.6 with a dash greater than and then libc-2.6.so. Hard links. While we are on the subject of links, we need to mention that there is a second type of link called a hard link. Hard links also allow files to have multiple names, but they do it in a different way. We'll talk more about the differences between symbolic and hard links in the next chapter. Summing up, with our tour behind us, we have learned a lot about our system. We've seen various files and directories and their contents. One thing we should take away from this is how open this system is. In Linux, there are many important files that are plain human-readable text. Unlike many proprietary systems, Linux makes everything available for examination and study. Further reading. The full version of the Linux Filesystem Hierarchy Standard can be found here. That's www.pathname.com/FHS/. An article about the directory structure of Unix and Unix-like systems are at Wikipedia under Unix directory structure. A detailed description of the ASCII text format are also at Wikipedia under ASCII.